the arc sine or the inverse sine of theta, your calculator is always going to give you back the acute angle.
On whatever form of assessment we have at the end of this week, do we have to memorize both laws, or can we use our sheets for that?
The laws of cosines and sine. No, you can use your sheets. I mean, if you don't remember the law of sines, that's pretty basic. And the law of cosines is basically the Pythagorean theorem switched around. And if I said no, all you had to do is turn around and look at the sheet on the wall. So anyway, so if you take the inverse sine of theta, you're always going to get back the acute angle, even when it's possible that you might have that corresponding obtuse angle will produce the same sine. So, and this occurs in a triangle when you have, like this side here, this is A, and this is B. This is angle A, so this is A, this is B, this is B, this is C, C. If I move this B in, then this angle here has a complementary angle 180, and that's the angle that you gotta be worried about. Because remember, you're given side angles, so you gotta find two angles. You gotta find this angle up here, and you gotta find this angle down here. But if we move B over to here, you see that we got two triangles that have the same size. This side and this side. If this was over there. Okay. So, how do we go about solving this side angle? How'd you do?
I think you went well.
I'm sure we did.
Hopefully.
Who were the,
It was just Mrs. Mordekaiser
faculty.
and Mr. Sweeney.
what's that?
Mrs. Mordekaiser and Mr. Sweeney.
Oh, Mrs. Sweeney was
Yeah.
there? Well, he was there for, Mallory's, but then I heard he's not there for all of them.
Yeah, he's only there for a couple, I think only today though.
Oh, really? Were you nervous?
Very.
Really? Mallory claimed she was nervous, but she did a really nice job. She was very poised. It's so easy to get nervous.
Yeah, it's scary.
What was your topic on?
I was researching if like teenagers now are less scared of horror than their parents.
Scared of cars?
Horror, like
Oh.
horror movies, because like violence in the media, you might be desensitized.
And?
I found that they were, yeah. Teenagers seem like less scared of horror than their parents, so I think that is like because of media.
How about video games?
I didn't research that. Maybe.
I would think that might play a factor
Probably.
too. So, well, interesting. Well, good. I'm glad it went well. All right. So for side angle. Okay. So now, when the homework that I posted, I said using the convention that we've been adopting in class. There was no way I was going to sit there and draw triangles. So again, basically our convention that we've adopted in this class is the angles are the lowercase and the sides opposite are the corresponding uppercase. This is how we've been doing it ever since we started this conversation, this topic. You know, some literature you might see it the other way around, but this is what we've been adopting. And there's no reason to change it. So with that as our backdrop, Notice you got, again, these 6 parameters that we're looking for. Right, and with side, side, angle, you are given 2 sides. Right? So, in the homework and however you see it, you know, I'm gonna try to be consistent just to make your life easier. But I think some of the problems I gave you, you had to think a little bit, just figure it out. But so, let's say I give you A and B. So that's how we're gonna go through these conditions when you got the 2 known sides are A and B. And the angle is A. So AB and the angle's A. So this is okay, right? Because remember, it's side, side, angle, which means the angle is not between the 2 sides. If it was side, angle, side, then it would have to be, with those 2 sides given, it would have to be angle C. But that's a side, angle, side triangle, which is not side, side, angle. The 2 sides, and then the angle not, one of the angles not between them. So we're gonna give you A, gonna give you B, gonna give you angle A, okay? So we got, like I said, in this situation, we got the possibility of there being no solution, meaning there is no triangle that satisfies those requirements. We got one solution or a unique solution. In other words, there's one triangle and only one triangle that satisfies those requirements. Or there are 2 triangles that satisfy. And if you look in the literature and stuff, they call that maybe the ambiguous case because of the fact that you got this situation where you got a choice of 2 angles and you don't know which one to use. So it's ambiguous, but you can use both of them, either of them, or both. So you got two triangles that satisfy those conditions. So those are the possibilities. So now the question is, how do you figure that out? So we're gonna do this relative to how the sides A and B relate to each other. How the sides A and B relate to each other. So first thing is, what if they are equal? Take the simple case first. So if the 2 sides A and B are equal to each other, then there is one solution. And you have all the tools necessary to figure that out, what that solution is. If A is greater than B, you have one solution. So those are the 2 conditions of how A and B relate to each other. A equals B, one solution. A greater than B, one solution. Can anybody guess what the 3rd way the 2 sides could relate to each other?
A is less than B.
A, very good. A is less than B. Now, here comes, in this condition is where the ambiguity could present itself. So there's subcategories here. So let's go over to here. So this is the case where A is less than B. And there are 3 things to check for this. If A is less than B times the sine of A. So in other words, if you look at the triangle, we're given A, we're given B, and we're given this angle A. So you have the information needed to do that calculation. You got the side B and you got the angle A. So B times the sine of A, if that is greater than A, or A is less than that product. No solution. When Connor comes back. Okay. Now we can go into a lot more formal discussion about why this is the case, because the way this is really coming down to, what you could do is like take this triangle and drop a perpendicular down and form the right triangle. Then you need to compute the height of that right triangle, and then go about it that way. So this is basically a, what's the right word? It's saving you the trouble from doing that. This is what would result if you did that. So this is where this comes from. So anyway, if this side A is less than this side times the sine of that angle, there's no solution. That's the case where it just wouldn't fit, wouldn't reach. You'd end up with something like this. Where a little guy just hanging out there. The second, we got A less. So now we want A equals. A equals that. Then there's one solution. Now I will admit, you're taking the sine of an angle, right? Unless you're taking the sine of like 90 degrees, which is what, everybody, sine of 90 degrees? One. Or you're taking the sine of 180 degrees, which is? Zero, right? Or the sine of 45, no, that's good. The sine of 30 degrees, that's like a half. Right? So where you get a nice number. It's going to be very rare that this condition is ever going to do that. Right? So you're looking for equality there. So if the side length of A is exactly equal to the side length of B times the sine of this angle, you got that condition. Right? Usually when you take the sine of an angle like 32 degrees or 47 degrees or something, that's going to give you a non-exact number. So if you multiply that to a side length, you're not going to get equality most of the time. So, but anyway, there it is. I mean, if you do, then there's one solution. And then the third case, Luke, you want to figure out what the third condition was? It's tough, man. I know. Do you want a minute to think about it?
Go ahead and go with it. It's A is greater than B.
Okay. Sure you don't want to reach out for some help for your helpline or whatever? Okay. So yeah, that's
No
the third.
phone a friend today.
So that's the third solution, or third possibility. And since you're on a roll, anybody, you want to guess what that would result in?
You got a 50-50 shot, huh?
Well, actually, you got a 33 and a third shot. Because the possible solutions are 0, 1, or 2.
Oh, there's a two solution possibility.
Well, that's what we're talking about, the ambiguous case. Right?
Oh, is that two solutions?
Yeah, very good. This is the only triangle for side-side angle that this ambiguous case results, usually. Right, so this is the only situation where you could have two solutions.